Hello and welcome to another exciting class. Today we're going to be talking about finding the volume of prisms. Now, just recapping, we've done surface area questions before. Surface area of any three-dimensional object can be found by just getting the area of each of the sides and adding them together. But the volume is the space inside a three-dimensional object. Now, when we're talking about a prism, what is a prism? Well, a prism is a shape where, if you look at the front of the shape and go all the way through to the back of the shape, it will be the same. So when you actually look at a shape like this is called a triangular prism, because if you look at it, there's a triangle at the front, there's a triangle at the back, and they are exactly the same size triangle. And that's the same if I actually cut this shape straight down the middle here. There's a triangle's always the same size. It's called a cross section. And it doesn't have to be a triangle. It could be another shape. It could be like this. It could be like a shoebox. A rectangular prism. Because each of the sides on this particular shape are rectangles. Now with this one, this is a little bit more unique because I could actually look at this particular question and I could say, well, I've got an area of a rectangle at the front. That's the same as the area of the rectangle at the back. So those two areas are the same. The slices from front to back are the same size rectangle, so I could actually do that. But with this one, I could actually say, well, look at this side rectangle. That's the side on the right side of the shape, if you like. That's the same as the area of the rectangle on the left side of the shape. So I could actually go from left to right, or right to left. I could also, if I wanted to, for this particular shape, look at the shape on the top. It's a rectangle on the top if I colour it in. It's a rectangle on the bottom if I colour that in, and they're the same size rectangles. So a prism that is rectangular can be actually sliced lots of different ways, but it doesn't matter. If you look at a slice at the front, here's a slice at the front and a slice at the back. If those slices are the same, then you have a prism. Now, don't forget that when you're dealing with these types of shapes, when your volume questions, you're always measuring in units cubed. So let's look now at the three formulas that show up on our booklet formula sheet. The first rectangular prism is drawn. It's just a rectangle base with a height. Length times breadth times height gives you the formula for the volume. Or you could do LBW or BWH. It doesn't really matter as long as you're multiplying the three dimensions together. If you have a cube, all of the lengths are the same. So instead of length times breadth times height, because they're all the same, we just go the length times the length times the length, or length cubed. I'll typically probably not use that formula written like that. I'll normally write this, side length cubed, because I think L can sometimes be mistaken as a 1, and I don't want to make any silly mistakes because I misunderstand my own writing. If you're dealing with any other type of shape that's a prism, then you just use the area of that slice, or the front slice, which is the same as the back slice, if you like, multiplied by the distance between them. And we'll do an example of that in a moment. So let's also talk about our conversions. We do know from the past, if let's say I wanted to go from meters to centimeters. Meters to centimeters, I'd normally times by 100. If I was going meters squared to centimeters squared, I'd times by 100 squared for area questions. But this is volume. So I'm going to go meters cubed to centimeters cubed, I times by 100 cubed. Let's say I wanted to go millimeters to centimeters. I'd divide by 10. But millimeters cubed to centimeters cubed, I divide by 10 cubed because it's three-dimensional. The other thing I need to be aware of is capacity. Now, capacity is when you're talking about how much fluid or liquid you can fit inside a shape. Now, if I actually talk about 1 centimetre cubed or 1 cubic centimetre, that would be like drawing a square 1 centimetre by 1 centimetre by 1 centimetre, then actually giving it some depth to make it into a cube that's 1 centimetre by 1 centimetre by 1 centimetre. And if I actually filled that shape up with water from top to bottom, then it would hold 1 milliliter. If I actually now wanted to look at the next concept, 1,000 centimetres cubed is a litre. This is the way I remember it. It's a really bizarre way to remember it, but I remember it from eating ice cream years ago. If I imagine an ice cream tub that was 10 centimetres by 10 centimetres by 10 centimetres. 10 times 10 times 10 gives me 1,000. And I know 10 centimetres by 10 centimetres by 10 centimetres is close to holding about a litre of ice cream, because 2-litre tubs are a little bit bigger than 10 by 10 by 10, so that's how I remember it, but you just need to remember it. And the last one is if you had a metre cubed, so if we had a big cube that was 1 metre by 1 metre by 1 metre, then that would hold 1,000 litres of water, or 1 kilolitre of water. So here's our first example. Now the first example looks a lot harder than what it is, because when you look at the shape you go, well, what sort of shape is it? It's got curves in it. But if you look at this bottom area and then you focus on the top area, they're exactly the same shape, which means the shape going from the bottom all the way through to the top is consistent, the cross-section is consistent. This is just a prism question. And to find the volume of a prism, we use our formula, the area of the base times the height. For this question, it's quite easy because the area of the base, I am told, area of that shaded grey bit is 15. So it's 15 times the height, and the height is 8. So that's 15 times 8, and 15 times 8 is 120, so I get 120 centimetres cubed for the volume for my unusual prism. Example 2 is a little bit more of a regular type of shape. It's actually got a triangle at the front, and if I looked at that triangle at the back, they're the same size triangles. I could actually, if I wanted to, even take a triangle in the middle, and it would be the same because it's called a cross-section. So this is a prism, and the formula for the area of a prism is the volume is equal to the area of my front bit, which is a triangle, times by the height. Now notice I used a capital H instead of a little h here. I haven't done that before. That capital H stands for the distance from this front triangle through to the back triangle, 7.5. Why did I use a capital H? Well, here's the reason. When I look at the area of a triangle formula, and I just put it in brackets there, it's a half base times height. That's a height, but they're different heights. This little h is the height of my triangle. The little b is the base of the triangle. The capital H is the height of my prism. That's the distance from the front to the back. So I can put those numbers in. It becomes a half times 4 times 3.6 for the triangle times 7.5 for the height of the prism. And when I put that into the calculator, the volume for this particular shape is 54 centimetres cubed. We go on to example number 3. This question could be done several different ways. I'm going to focus on looking at the rectangle at the front. There is also a rectangle at the back that would be the exact same dimensions, which means from front to back I have the same shape. This is a prism. Now the formula for the volume of a prism is the area of the rectangle at the front times the height. The rectangle at the front is 12 times 4 or 4 times 12, the height 15, and I get my answer of 720 centimeters cubed. It would have been faster to use this formula. Length times base times height, which becomes, and it doesn't matter which way you do it, but let's go 12 times 4 times 15, which gives me 720. Now I say it might have been quicker, but when you actually look at the working now, it's exactly the same really, just a slightly different way of writing the formula. Now this question said to find the volume, but then it says what's the answer in litres. Now what we do need to remember is this. I said before, 1 cubic centimetre would hold 1 millilitre. And remember, 1 millilitre is 1,000th of a litre. So if I have 720 centimetres cubed, that means it would be 720 millilitres. Now I know a milliliter is 1,000th of a litre, so I divide that by 1,000 and I get 0.720 or 0.72 litres for the capacity of that particular prism. And that's how much the shape would hold of fluid. Well, time for you to try some questions now for 5G. Enjoy the experience, and if you've got any queries, you can ask your peers or myself later or Mr. Appel, and good luck with them. Bye for now.